Hello. Hello and welcome to this video on multithreading with C. In this video, we will talk about condition variables, what are condition variables, how they are used, why they are used. So let's take an example of two threads. Okay. Now let's assume that the two threads are waiting for one particular mutex. Okay. Now we have one mutex here and there are two threads. Now they will acquire the lock. Okay. Now what will happen is that one lock will be acquired, the other thread will wait for the mutex to be unlocked. Now, when the mutex is unlocked, the other thread doesn't know that mutex has been unlocked. So you use condition variables to signal to other thread that the mutex has been unlocked. Okay. Now let me see this compilation problem. This is going to, okay, this is a wrong place. Okay, this shouldn't be there. Okay. Anyway, so what I was saying is that, so in case of two such threads, we need some mechanisms for the thread which has the access to the critical section to signal to another thread that you need to wake up and do your work. And condition variables are used for that. Let me compile this code quickly to see that it is proper. 1.c. Okay. So first we look at the man page of pthread underscore con underscore init. So con here means condition variable. Okay. So we have quite a few functions here. First is the static variable. Pthread con initializer is used to initialize the condition variable. Then we have dynamic ones. We have pthread con t, which will take a dynamic condition variable along with the attributes of condition variable. Then we have signal to broadcast, not broadcast, to send the waiting thread the signal. Then we have broadcast to send signal to every thread which is waiting on the condition variable. Then we have wait, where we can wait on the condition variable. And we have timed wait, where we wait for certain time and then time out. First, we will look at timed wait. We will not cover time cond wait yet. And then finally, we have pthread con destroy to destroy the condition variable, the dynamic one actually. So we'll go through this man page and then we'll see the example. A condition, short for condition variable, is a synchronization device that allows threads to suspend execution and relinquish the process until some predicate on shared data is satisfied. The basic operations on conditions are signal the condition when the predicate becomes true and wait for the condition, suspending the thread execution until another thread signals the condition. A condition variable must always be associated with the mutex. This is important. A condition variable is always associated with the mutex. It is not a synchronization mechanism, it is a signaling mechanism. To avoid the race condition where a thread prepares to wait on a condition variable and another thread signals the condition just before the first thread actually waits on it. Pthread underscore cond underscore init initializes the condition variable cond using the condition attributes specified in cond underscore attr or default attributes if cond underscore attr is null. The Linux threads implementation supports no attributes or conditions since the cond underscore attr parameter is actually ignored. Variables of type pthread underscore cond underscore d can also be initialized statically using the constant pthread cond initializer. Then we have pthread cond signal restarts one of the threads that are waiting on the condition variable cond. If no threads are waiting on cond, nothing happens. If several threads are waiting on cond, exactly one is restarted, but it is not specified which. Then we have broadcast, which restarts all the threads that are waiting on the condition variable cond. Nothing happens if no threads are waiting on cond. Then we have cond wait, automatically unlocks the mutex and waits for condition variable cond to be signaled. The thread execution is suspended and does not consume any CPU time until the condition variable is signaled. The mutex must be locked by the calling thread on entrance to pthread found wait. Before returning to the calling thread, pthread found wait reacquires the mutex. Unlocking the mutex and suspending on the condition variable is done automatically. Thus, if all threads always acquire a mutex before signaling the condition, this guarantees that the condition cannot be signaled between the time a thread locks the mutex and the time it waits on the condition variable. We have caveats below. The thread con underscore time wait atomically unlocks mutex and waits in con, as pthread con wait does, but it also bounds the duration of the wait. If con has not been signaled within the amount specified by absolute time, the mutex is reacquired and pthread con time wait returns the error we timed out. Absolute time parameter specifies an absolute time with the same origin as time and get time of day. An absolute time of 0 corresponds to 00:00:00 GMT January 1, 1970. Pthread con destroys the condition variable, freeing the resource it might hold. No threads must be waiting on the condition variable on entrance to pthread con destroy. In the Linux threads implementation, no resources are associated with condition variables. Thus, pthread con destroy actually does nothing except checking that the condition has no waiting threads. We have cancellation. Pthread con wait and pthread con time wait are cancellation points. If a thread is cancelled while suspended in one of these functions, the thread immediately resumes execution, then locks again the mutex argument to pthread con wait and pthread con time wait, and finally executes the cancellation. Consequently, cleanup handlers are assured that mutex is locked when they are called. We have async signal safety. The condition functions are not async signal safe and should not be called from a signal handler. In particular, calling pthread con signal or pthread con broadcast from a signal handler may deadlock the calling thread. Return values are all conditional variable functions return 0 on success and non-zero error code on error. So we have errors. So these functions never return an error code. Pthread con timed wait function returns the following error codes on error e timed out. The condition variable was not signaled until the timeout specified by absolute time. The pthread con destroy function returns the following code on error e busy. Some threads are currently waiting on con. Then we have caveats. The implementation of the provided function until glibc 2.25 used an internal data lock. The lock did not support priority inheritance and was subject to unbounded priority inversion visible on a real-time system. After the rewrite of the implementation in glibc 2.25, the uses of internal lock change. The internal lock is always acquired by the signaling functions pthread con signal and pthread con broadcast. The waiting function acquires the lock if the waiting process was interrupted. The interruption can be used, for instance, by a specified timeout and denoted by the error value we timed out A, or by a received signal which is denoted by the error value E interrupt. So we will look at the example after we look at our own example. So first is a static condition variable initializer. So you can have a structure like this, where the value is the data which is to be protected by mutex. Mutex t is the mutex variable which will protect this value, and cond is the signal which will signal the change of the value. So how do you initialize this? You have data variable of my struct stack, and you specify pthread mutex initializer and pthread cond initializer. So this is how you initialize static one. For the dynamic one, you will have pointer of that. Okay. So for example, here we have my struct tag and you create a pointer. Okay. And then in the mutex init, you specify ampersand data arrow mutex, that is the dynamic version. And for cond init, you specify ampersand cond init. And also for cond destroy, you give ampersand data cond and ampersand data mutex. So this will destroy the mutex. Now the main example which we are going to see is this example. So let's look what it does. Okay. So let me show you from beginning. We have a my struct tag, mutex, and condition variable along with value. We create a static variable of this using the said mutex initializer and cond initializer. Our hibernation is 1 second. Remember that. Okay. Now Okay, so there is something wrong. Okay, it should be like this over here. So we sleep for some time, okay, and then we acquire lock. And after acquiring lock, we change the value of data to 1. Okay, initially it would be 0 here. We change the value to 1, then we signal if any thread is waiting to wake up, and then we unlock the mutex. Simple. Okay, and finally we return null. So here we receive the argument here. We don't do anything with the argument. Now in the main function, if the argument c is greater than 1, we set the argument to hibernation. Okay. Now we create the wait thread here. You can see the function here, and then we uh, proceed with the logic. So we create a time spec structure for 2 seconds. Okay. And we take mutex lock on the data mutex. Now, if the status is not equal to 0, we say that mutex is locked. Okay. Now we check whether the data value is 0 or not. If it is 0, we wait for certain time. Okay. The timeout is 2 seconds here for this each thread can't wait. All right. Now, if the status is timed out, then we say that condition is timed out and we break out of this loop. If status is not equal to 0, then we say we wait on condition. Now, if data value is not equal to 0, after the while loop, we say condition was signaled and we unlock the mutex, and finally we print unlock mutex if the status is not equal to 0. So usually whenever the status is not equal to 0, we print something, otherwise we don't print. Over here we have condition was signal, that is the main thing, and condition with timed out. These two are main messages which we have. And the other thing is that hibernation is determined by the argument, and initially we wait for 1 second here. All right. So let's see this in action. So we compile this gcc minus vol minus w error minus ftd is equal to c23 minus pedantic, and then we do on.c, and then we run this, and condition was signal. So why the condition was signaled is because our sleep without argument is 1 second. Okay, and this thread, the second thread, will wait for 2 seconds, but before the timer can expire, we receive the signal. Okay, so the status won't be timed out because before this expiry we have this status which will be we will have status which will be 0. Okay, so since this t-thread can't wait is signal and status is not equal to 0, and data dot value will be non-zero here, because you remember after changing data value this will be 1. So it will be signaled that okay, you can now proceed. So it will run the logic, it will see data dot value is 1 and it will proceed, and then it will see the value is not 0, so condition was signal was printed here. Okay, now what if we increase the hibernation? We can say hibernation for 2 seconds. Okay, so this time it will time out because this thread now sleeps for 2 seconds before running, and this thread will wait for 2 seconds. So actually the second thread takes time to execute, and therefore the timer expires here, and it says condition wait timed out, and finally it does not print that condition was signaled. Okay, so that's the entire logic, and I hope that you have understood this very simple program. Now we will go back to our example of man page. Okay, so consider two shared variables x and y protected by a mutex mut and a condition variable con that is to be signaled whenever x becomes greater than y. Waiting until x is greater than y is performed as follows. You take the lock on the mutex and you wait. while x is less than equal to y, you wait here. Okay. And then you operate on x and y, and then you unlock the mutex. Modification on xy that may cause x to become greater than y should signal the condition if needed. So take the lock, change x and y. If x greater than y, then you broadcast or signal, and then you unlock the mutex. If it can be proved that at most one waiting thread needs to be waken up, for instance, if there are only two threads communicating through x and y, two-thread count signal can be used as a slightly more efficient alternative to pthread count broadcast. In doubt, use pthread count broadcast. To wait for x to become greater than y with a timeout of 5 seconds, we have seen this example where we gave the timeout to 2 seconds. Okay, so that's the end of the man page. So our program essentially is similar to man page. We wait for our predicate in while loop, and when the predicate becomes true, that is data value is equal to 1, and we receive the signal, we immediately break from the loop. That is, we don't break actually in the programming sense. Our predicate becomes true, and we don't. Our while loop is terminated, and we print that. Okay. So with this, I think I will end this video here, and in the next video, we can probably see broadcast in action. Here it was signal. Okay, thread count signal. In the next video, most probably I will show you the broadcast where more than two threads may be in picture. So I hope that you have found this video useful and you got something to learn. So we'll meet again after 4 days with another video on multithreading on C. Till then, stay curious, keep learning, and most importantly, enjoy.